Hello everyone. Today we are going to discuss optics. Optics generally it has two parts. One of the part is ray optics and other one is a wave optics. So ray optics we are going to go through in more details. I have discussed in previous videos regarding the light, right? Light was considered to be made up of, it was considered to be ray, and then Newton's corpuscular theory came up. So all those discussions are there, out of which later on it was concluded that light also has got a ray character, as well as light can also be considered as a wave. So considering light as a ray, right? So in the ray optics we have two topics to be discussed. One of them is reflection and the other one is refraction. Reflection I have already discussed, and refraction is one which we are going to start today. So refraction, defining refraction you can call it as it is a bending of the light ray when it travels from one medium to other medium. Bending of the light ray while traveling from one medium to other. What do we mean by this? It means that when the light ray it travels from the sun to the earth, right? There are various mediums present in the space. We consider there is no medium at all, and as soon as the light enters the earth, light will travel through the air, and after traveling through the air, it may enter into water, it may enter into any other liquids, right? We may have a piece of glass, so light when it enters into the piece of glass, so in all such cases we say that medium changes, and whenever medium changes, light suffers refraction, and refraction means bending of the light rays. To understand, if I take an example, let's say one of the medium given here is air. Let's say light is traveling from air, right, and it is entering into the water. So let's say the light ray was traveling somewhere like this, it entered into the water, it will bend. See, it was this dotted line shows the initial path of the light ray. Rather than going straight, it got bended. So we are going to see why does the light ray bends. So one of the most important cause that why light ray bends, the reason is change in velocity. Whenever the medium changes, velocity changes, and change in velocity is the main reason that why the light suffers such type of change in the path. Change in velocity, it is the reason why light ray bends. When the light ray travels while traveling from one medium to other medium, frequency is not going to change, neither phase is going to change. Frequency and phase, they remain same. It's only the velocity changes, and because of velocity the wavelength also changes. So refraction, bending of the light ray while traveling from one medium to the other medium, right? So if I take this diagram, let us understand the various terminologies associated with the refraction. So to understand terminologies, I'll draw one more diagram. Same diagram, I'll draw it little better, right? Ray of light is traveling from medium 1, right, and then it is entering into medium 2. This is the medium 1, I call it as a rarer medium, and this is the medium 2, which is a denser medium. Denser in the sense its density is more as compared to the first medium. If you compare air and water, water has a more density than the air. So with reference to this diagram, this ray of light which is traveling towards the interface, this is called as a interface. Interface, it is a boundary which separates the two medium. So ray of light traveling towards the interface, we call it as a incident ray. This incident ray, wherever it strikes that point, we call it as a point of incidence. At the point of incidence, we draw one 90-degree line, one reference line which help us to understand the refraction. This 90-degree line, we call it as a normal. The angle between the incident ray and the normal, we call it as angle of incidence, and the ray of light which emerges out into the second medium, the ray of light which enters into the second medium, this ray of light we call it as a refracted ray. Since it has bent, we call it as a refracted ray. The angle between the refracted ray and the normal, we call it as a angle of refraction R. So these are the terminologies: incident ray, angle of incidence, normal, point of incidence, refracted ray, angle of refraction, and the interface. So based on these terminologies, let us understand the refraction in more detail. So we have the laws of refraction. So laws of refraction, the first law which says that, right, the incident ray, refracted ray, and the normal, they lie in the same plane. They lie in the same plane in the sense that you can draw a plane, right, wherever your incident ray is. Let's say if the incident ray is on the board, right, and this is a true interface. Let's say above this line there is air and below this line there is water. So if incident ray is on this board, right, normal you draw at the point of interface, and then you have a refracted ray. All three of them for sure you can consider it on the one single plane. Not consider, they are for sure on this one single plane. Then the second law, the more important one, also called as a Snell's law. It states that sine of angle of incidence to the sine of angle of refraction, it always remains constant. It means that even if you change angle of incidence, you will get some angle of refraction. You can do those measurements by some practical methods. So when you change angle of incidence, you will get some angle of refraction for every incidence, every incident angle, and for every refracted angle. If you take the ratio of their sine, for sure that ratio you will always get a constant, and this constant we call it as a mu, called as refractive index of the medium, right? It has entered from medium 1 to the medium 2. So sin I by sin R, this ratio, it always we get a constant, and that constant we call it as a refractive index of the medium. To write it in a more clear way, since we have two different medium whose refractive index is this, so writing it more specifically, it can be written as refractive index of medium 2 with respect to medium 1, right? Ray of light is traveling from 1 and it is entering into the 2, so refractive index of the medium 2 with respect to 1 given by sin I by sin R. This is one important formula, very much helpful from the numerical point of view. This formula can be further rewritten as mu 2 by mu 1 is equals to sin I by sin R, right? Mu 2, it is the refractive index of the medium 2, and mu 1, it is the refractive index of the medium 1. When we say refractive index of the medium 2, we mean that it is the absolute refractive index of the medium 2. How do you calculate the absolute refractive index? The word absolute means the bending capacity of that particular medium. Here we have got bending capacity of the medium 2 with reference to medium 1. But let's say if I want bending capacity of only the medium 2, how do I get? So let's see that, and this is the refractive index of the medium 1. Now let's say if the medium 1 is vacuum, or even if you take it as air, the refractive index for the air or vacuum, it is taken as 1, right? And mu 2 we will replace by mu. So the above formula can be written as mu is equals to sin I by sin R. Here if we write this formula in terms of the velocity of the light, it can be written as v1 by v2. v1 is the velocity in the medium 1, v2 is the velocity in the medium 2. We have taken mu1 as 1, so for sure the first medium, the velocity will be equal to velocity in the air. In the first medium, the velocity is equal to velocity in the air or in vacuum, that is we know is a constant 3 into 10 to the power 8 meters per second. So substituting even this one, mu equal to sin I by sin r, we get it as c, and v2 also, v2 we will substitute as v. So mu is equals to c by v. This is how we get absolute refractive index, that is the bending capacity of that particular medium. If I want the bending capacity of the medium 2, right, I wanted the bending capacity of the medium 2, so I have taken first medium as air, right, and since the first medium is air, the velocity in the first medium will be c. Let's take an example to understand the absolute refractive index in a much better way. Let's say medium 1 is air. We are calculating the bending capacity, right? We are trying to calculate the absolute refractive index. So let's say medium 2 is glass. So medium 2 is glass. So if you want bending capacity of only glass, for sure you must take a medium 1. Instead of air, if you take medium 1 as water, you will get refractive index of glass with respect to water, but this will not give you the absolute refractive index. If you want absolute refractive index, for sure the medium 1 must be air and medium 2 must be glass. So if we take this condition, then refractive index of the glass will be c, that is the velocity in the medium 1, right, and v2, that is velocity in the glass. So this is how we get absolute refractive index. Refractive index, it can be, this is one formula, this is another formula in terms of the velocity of the light, right. Velocity can be further written as frequency into wavelength. As per the laws of refraction, right, it has been experimentally proven that frequency do not undergo any change. So mu will be equal to lambda 1 by lambda 2. This is another formula of the refractive index in the terms of wavelength of light. Wavelength of light in the medium 1 to that of the wavelength of light in the medium 2. In this one, further, if we take lambda 1, medium 1, if we take it as air, let us replace it by lambda naught, and lambda 2, let us say it is some given medium, neither glass nor water. Let's take generally that if it is given some medium, then refractive index mu will be equal to lambda naught by lambda m. So wavelength in the medium will get reduced by the refractive index mu. So this is a conclusion obtained from this one. Then regarding the bending of the light ray, right, taking this formula, right, how this bending will take place. This bending will be either towards the normal or it can be away from the normal. So on what basis do we conclude? So taking this formula, mu is equals to v1 by v2, right, that is equals to sin I by sin r. This one you can take it, this is as mu2 by mu1. I have taken mu2 and mu1, it can be any medium. So here case number 1, let's say if the v1 is greater than v2, if v1 is greater than v2, for sure sin I must be greater than sin r. We can further conclude that angle of incidence is greater than angle of refraction. The incident angle will be greater than refraction. So since velocity is more in the medium 1, velocity is less in the medium 2, that means medium 1 is a rarer medium and medium 2 is a denser medium. So when a ray of light travels from rarer to denser medium, right, it will bend towards normal. So this rule, it has come from this conclusion. that if the velocity in the medium 1 is more, that is medium 1 is a rarer medium, just like this example, if the medium 1 is a rarer medium, medium 2 is a denser medium, which ultimately leads to the conclusion that sin I is greater than sin R, which further can be reduced as I is greater than R, and finally we conclude since I is greater than R, the ray of light will bend towards the normal. Second case, if V1 is smaller than V2, that is V1 is a denser medium. I'll draw it up here, right? Let's say if this is the medium 1 which is denser, and here we have a medium 2 which is rare medium. So you can say that light is traveling from you may say from the glass to air, right? For example, you may take it as the ray of light is traveling from glass to air. So once again, at the point of incidence, we'll draw a normal angle of incidence. So let us see how the light ray will bend. Its original path was this. So will it bend towards the normal? Will it bend away from the normal? So from this, we can conclude that sin I is smaller than sin R, which ultimately leads us to the conclusion that I is smaller than R. And hence we conclude that when the ray of light travel from denser to rarer medium, when the ray of light travel from denser to rarer medium, it will bend towards normal. It will bend away from the normal. Angle of incidence is smaller, angle of refraction is larger, so it will bend away from the normal. And the drawing would be something like this. So it will, rather than going towards normal, it will go away from the normal. This angle of refraction will be more than the angle of incidence.